Okay, so here's a classic problem where we have to rationalize the denominator. Because if we remember our three no-nos, the third no-no is we cannot have a radical in the denominator. We do have a radical in the denominator, so that's a no-no. So how do we take care of it when we have a binomial denominator, where one or both terms are radicals? Well, we multiply by the conjugate. Remember we showed earlier that the conjugate will rationalize. If you multiply two conjugates, you get a rational number, so we can rationalize by multiplying by the conjugate. So the conjugate of 5 minus radical 3 is going to be 5 plus radical 3. So multiply the top and the bottom by 5 plus the square root of 3. And that's multiplication with conjugates. Now when we multiply the top, we don't really have to worry too much about that. We're usually worried about the bottom. So that's just going to be 2 times 5 plus the square root of 3. And sometimes it's best just to leave this factored out because it may simplify. Now on the bottom, when we multiply this, and we'll just do this, what's 5 times 5? That's 25. And 5 times the square root of 3, the outside terms, and this is negative 5 times the square root of 3, these become 0. Again, watch. Outside, inside. 5 times the square root of 3 and negative square root of 3 times 5, which is the same thing as negative 5 times the square root of 3. Positive 5 square root of 3, negative 5 square root of 3, that's 0. You could write it out if you want. We did some of those early, but that's just 0. And then a positive times a negative is a negative. And what's the square root of 3 times the square root of 3? That's just 3. You're going to get a nice rational number in the bottom. And then we could leave the top like that. 2 times 5 plus the square root of 3. That's okay. And in the bottom, what do we have? 25 minus 3 is 22. And you can see that 2 goes into 22 11 times, so that even simplifies more to be 5 plus the square root of 3 all over 11. So that's why it's nice just to leave it like that, because you may be able to simplify. So these are your classic problems. Now sometimes they're a little bit more challenging. Sometimes you might have a binomial in the top. So here's an example. Well, something like this. Okay, so again, when we look at this, we say, do I have a radical in the denominator? Yes, so I got to fix that. So that's one of my no-nos. No square root of the denominator, so I have to multiply the top. So it's real simple. You just multiply the top and the bottom by the conjugate. Only we're going to have to do some binomial multiplication over here. So we're going to multiply the top and the bottom by the conjugate of this, which is the square root of 5 plus 2. Okay, so on the top, we're going to have to do the FOIL process, and these terms are going to be all messed up, but that's the way it goes. First term times first term, that's going to be 3 times the square root of 5. And the outside terms, that's going to be 3 times 2 is 6. Inside terms, the square root of 7 times the square root of 5 is the square root of 35. And then the last term is 2 times the square root of 7. So it's a big old mess up on the top. We're not worried about the top, we're worried about the bottom. And remember, when we multiply first term times first term, that's going to be square root of 5 times square root of 5, which is just 5. And again, 2 times the square root of 5 and minus 2 times the square root of 5, they become 0. Those inside-outside terms zero each other out, or like you'd like to say, they cancel. And then what's a positive times a negative? Negative, and 2 times 2 is 4, so 5 minus 4. And that's just 1. So our answer is just going to be what we have in the top, 3 times the square root of 5 plus 6 plus the square root of 35 plus 2 times the square root of 7, and that's your answer. That's all you can do. There's no way to simplify this. Okay? Let's try another example here. Well, here's one that I was going to save because this is a little bit harder. Let's take a look at this one. Over here. And again, we've got radicals in the denominator. We got 2 actually, so we're going to multiply by the conjugate again. And that's kind of like the magic pill. It takes care of everything. So it's going to be the conjugate of the denominator here. So it's going to be the square root of 7 minus the square root of 3. Exactly the same thing, except the sign in the middle is the opposite, and those are conjugates. Now up on the top, we've got some foiling to do, so let's do that. So 2 times the square root of 7 times the square root of 7, so that's going to be 2. And the square root of 7 times the square root of 7 is the square root of 49, which is just 7, so 2 times 7. Okay? And if I look at my outside, I've got 2 negative. Positive times a negative is a negative. And I've got 2 times, and 7 times 3 is 21, 2 times the square root of 21. So that's my outside terms. Okay, negative 2. And the square root of 7 times the square root of 3 is the square root of 21, and there's a positive times a negative. And then my inside terms are going to be negative 3 times the square root of 7. And my last terms are going to be a negative times a negative is positive, and then 3 times the square root of 3. So it's kind of messy like my last one. And in the bottom, well, the square root of 7 times the square root of 7 is just 7. And then this is going to be negative the square root of 21 and plus the square root of 21, so that becomes 0. And then this is going to be negative, and the square root of 3 times the square root of 3 is 3. So finally our answer will be, what's 2 times 7 is 14, minus 2 square roots of 21, minus 3 square roots of 7, plus 3 square roots of 3, and that's all going to be all over, and 7 minus 3 is 4. So there's your answer. And that's all you can do with that. But we have rationalized the denominator. We do not have a radical in the denominator anymore. Okay? So just multiply by the conjugates, and you shouldn't have any trouble. Just the exact same thing in the bottom, except reverse the sign. Okay? Let's say we do have time for one more. Let's try one more. 5 all over 2 square roots of 10 plus 5. So again, we got a radical in the denominator, so we have to multiply the top and the bottom by the conjugate, which is 2 times the square root of 10 minus 5. And if we multiply, we have 5. And I'll just leave the 5 out in front because I might be able to simplify it. And on the bottom, 2 times 2 is 4. And the square root of 10 times the square root of 10 is just 10. And then again, this is going to be negative 10 times the square root of 10 plus 10 times the square root of 10, so they will always zero out. And then a positive 5 times a negative 5 is a negative 25. And this is just 40, so that's 15, so we have this equals 5 times 2 times the square root of 10 minus 5 in the top. And in the bottom, 40 minus 25 is 15, and we see that 5 goes into 15 3 times, so we can simplify that. 2 times the square root of 10 minus 5, all over 3, because 5 goes into 15 3 times. So there's your answer. Sorry about that. So again, rationalizing by multiplying the top and the bottom by the conjugate of the denominator.